Check. Okay, I think it's time. Let's get started. Can you guys see my screen now?
Yeah, we can see it.
Okay, great. Thank you. So, hello everyone. Thank you for joining Harbor Community Conference call. I'm the host of this meeting. I'm Steven Zhou, the Harbor maintainer. So here is the agenda for today's meeting. We have three main topics. The first one is I'd like to invite our product manager, Alex Xu, to talk about more about the next release, version 2.0. And after that, I'd like to invite Ziming Zhang from VMware Harbor team to talk about enable GitHub action to drive the Harbor CI process. Last, we would like to invite Henry Zhang to talk about a Harbor use case, the Harbor plus the Fate use case sharing. Okay. So the first topic, I'd like to invite Alex Xu to talk about the more about the next release. Alex, are you there?
Yeah, I'm here. Can everyone hear me?
Yep.
Yeah, go ahead.
Okay, so I'm just gonna go down the list of the things that we're working on for Harbor 2.0. So the latest release is Harbor 1.10, and essentially we are going to do quite a bit of refactoring to support OCI. So we're calling the next release Harbor 2.0. So the first thing is OCI support, and that's something we've talked about in the last couple of meetings. We're finally fully committed to completing the OCI support, or at least a big chunk of it. And the idea is for Harbor to host or to extend support for new cloud native artifact types, right? Such as operators, bundles, RPMs, etc. Beyond just Helm charts and container images, which is what we have right now. And this is done by following a common set of industry favorite APIs, right, called OCI, Open Container Initiative. And the real value for this is basically separating a lot of the features that we have right now from the artifacts themselves. So sort of abstracting them into more policy-driven capabilities. So you can implement one feature and be able to apply that to different artifacts in different ways through policies, right? Based on the signature type of the artifacts. The second one here is called tag deletion. And this is something that the community has asked for repeatedly, and it's been a problem for us in the past. And this is basically like a direct beneficiary of the OCI refactoring. So currently there's no way to delete a single image tag without deleting all the other reference image tags, sharing that shot digest. It's a limitation of the Docker registry that we're consuming because it only implements the deletion of the digest. So the way we're resolving this is we're going to add a new data structure called a Harbor tag that's basically one-to-one with the actual Docker image tag, and the user on the front end through the Harbor UI or curling into the the Docker registry only operates on the Harbor tag. So you're not actually operating on the Docker image tag. So to the user, from the user's POV, it's indistinguishable from working on the existing image tags, right? But it's much safer that way. So online GC is something that we have right now. So when you run garbage collection, it doesn't take the instance down, so it's still online, but it does put Harbor into read-only mode, which means that you can't push images to it. And depending on the size of your image set, that can take quite a while, right? If you have terabytes of data or more. So the goal is to deliver a non-blocking GC, which means that users can push and delete images from the Harbor registry while garbage collection is ongoing. So it runs silent in the background, and there's no possibility of image corruption when you push artifacts to it. This is really, again, this is a limitation of the Docker distribution itself, because it doesn't open up the, it doesn't expose the API for deleting the image blobs directly. But so we have a workaround because we consume the source code directly. So this is also something that we plan to finish in the Harbor 2.0. P2P Dragonfly, Dragonfly is it's a popular P2P distribution tool, as well as Uber Kraken. So these are tools that we're looking to leverage to better distribute images from within the Harbor registry to lots of other Docker hosts. So you can sort of picture this hub spoke model where the registry sits in the center, and you want to use something like Dragonfly or Kraken to concurrently push images outward, right? So they have a much more efficient, a more elegant peer-to-peer solution instead of just adding load balancers everywhere, right? And they also have mechanisms to preheat an image that that are going to get pulled, and different policies that can trigger promotion to their supervisor node. So this is something we're working with the community on. We have external maintainers and other people in the community that are very interested, and we have a working group on this that meets every Thursday. If someone is interested in this, please let me know. We have one tomorrow night, actually, 9 p.m. Beijing time. Webhooks, this is just extending current webhooks, adding additional webhooks for some of the features that we added in 1.9 and 1.10. So webhooks associated with tag retention, tag immutability, things like that. And finally, Docker Notary is tackling image signing for a multi-registry world. So this means persisting the image signature across image syncs in different registries. And so we're following the progress on the Docker Notary side to sort of drive our requirements on that end. And so hopefully, we'll work with the Docker guys to get something done in the next release or two. So that's just sort of a high level overview of some of the larger features that we're working on for Harbor 2.0. There's a project board on the GitHub repo, which is, it's a great way to keep track of the things that we're working on. It has links to PRDs, links to the actual epics, and then the breakdowns of the stories. And so, we encourage everyone to participate on GitHub and to raise concerns or questions if you have any. So that's sort of a 2.0 overview. And we'll go into more details on some of the features in the meetings to follow.
Okay, thank you, Alex, for the great sharing. I think V2.0 is another major milestone for Harbor project. And if you have questions, you can keep them, and you can ask in the Q&A stage. So let's move on to next topic. Next one is we're talking about the Harbor CI processing improvement. Will enable GitHub Action to drive the Harbor CI pipeline. So I'd like to invite Ziming Zhang from VMware Harbor team to talk about the details. Ziming, do you need to share your screen?
Yeah, I'd like to share.
Okay. Go ahead.
Okay, can you see my screen? Hello,
Yep.
Can you see me? Okay.
Yep.
Okay, as everyone know, Harbor before use the Travis to do CI. When you commit a PR or push to a branch, it must pass the Travis CI. And
Hello? Is it the
sorry, can't you see my browser?
I can, and I can hear you fine.
Okay, I'm showing the Travis UI. Can you see it?
Yep.
Okay.
Yeah, we can all see that. Thank you.
Oh, sorry. Let me share again. Can you see it?
Yes,
Oh,
well, not
to me? We can
anymore.
see your screen. You can go ahead.
Not anymore. I think he stopped the sharing.
yeah. I try again. Sorry.
Perfect.
Okay. As you can see, this is the Travis CI we are currently using. When you submit a PR, it will be checking by this Travis, and we will do some checking like UT test, API test, and also UI test. Travis is good, but there's some challenge for us that we are using the free version of Travis. So the main challenge is we can only run 2 concurrent job in Travis. So when there are many developers submit code, they have to wait quite a long time to wait the Travis checking done. Then his PR can be merged. So recently, GitHub provide the new actions, which is also target for the CI check. So we have introduced this, and as you see, this is the action screen. Also, for example, when user submit a PR here, and let me see another. When use I have to find some PR that carry into the master. Sorry, wait a moment. Okay, anyway, I mean, when user submit a PR, it will auto trigger the CI, the actions job here. As you can see, this action CI also cover the 5 test jobs as the Travis. And currently, GitHub Actions don't have limitation for public repository. Here, you can see about the GitHub action about the billions. It is free for public repositories. So if this is true, we can have more resource to do the CI check and do it quickly. And this PR is what I have done to introduce the GitHub action. As you can see, we just need to create a YAML file in the GitHub workflows folder like this, and this field will define the environment and the host which the host image which will run the CI scripts, and the jobs. Here are 5 jobs: UD test and API test and others. And also and also in each job, there are steps that we can define, such as we can define how to set up the environment, like set up Docker, set up Go, and how to run the test script here, like run ut run, and you can have you can see the detail running log in action screen here. As you see, the time GitHub action used is similar to the Travis, which is about 20 minutes. But the most benefits is we can run concurrently jobs. We can run more concurrently jobs. And another interesting thing is we may is GitHub action also allow to use self-hosted VMs. That means we can create a VM in our company intranet, set up a VM, and it will register the VM to the GitHub and listen on the GitHub pull request and run the job locally. That will make us be able to run some interesting thing. Maybe we can deploy Harbor in our intranet, and maybe test some other commercial things. Okay.
Okay. Per time limitation, I think you can close your topic. I think the most advantage of this is we can increase the concurrent job at the same time, right? Improve the productivity when there are many PR submitted to Harbor repo, right?
Yeah.
Okay.
Okay.
For time limitation, let's directly move to the third topic. I'd like to invite Zhang to share about the Harbor and Fate plus the machine learning scenario. Henry Zhang is the Harbor founder and maintainer. Henry, are you there?
Yes, I'm here. Do you want?
Okay.
Can you stop sharing?
Yeah.
Thanks. Let me share my desktop first.
So I think time is too tight. We only have 9 minutes.
Okay, I can go fast. Okay. Can you see my screen?
Yes, we can.
Sure. Yeah, cool. So I'm going to quickly talk about some of our integration for Harbor with another open source project called Fate. It's in the AI area called the Federated Learning. So let me give some quick intro about some of the background about this project. It's like in the AI industry right now, the success of AI lies in two important things. One is the computing power. The other is the big data that can be trained into a useful model. So for the computing power, it can be relatively easy to achieve because you can pay for some money and you can buy good AI chips like GPU or TPU, or you can rent some from in the cloud. But the other factor, the other elements like big data is hard to get. So nowadays, many people think the most valuable resource is no longer oil, but data. The big companies like Google, Facebook, and Microsoft, they have a large amount of data that can be used for training into a good model and be used to create many useful or interesting AI applications. So one of the important things is that as long as we have good data, even though you don't have a good algorithm, you can still be able to obtain some of the good application in the machine learning area. But the reality is that the data can be separated or fragmented into different organizations, or even inside the same organization within different departments. So it's hard for the users to get the necessary data to train a useful data model. So there's a statistic saying that about 80% of the enterprises they have information silos that cannot share the data to build an interesting model for the AI or machine learning applications. And furthermore, there is some regulations in everywhere that prevent the use of consumer data, like the GDPR that was implemented last year in Europe, and also in California and US, there's a CCPA, Consumer Privacy Act, that will be maybe effective next year, just 2 weeks away. And also in China, there's cyber security law that's protecting the consumer data. So this all kinds of regulation, as well as and the reality of the enterprise that having isolated data will prevent the application of the machine learning to build a powerful or interesting data model. So we have a dilemma here that we need to build a good application based on a large amount of data, but we cannot do it because we have the regulation, laws, enforcement here, and also we have other business reasons that would prevent us from doing so. So what do we do? And we have a way or core technology in the AI or machine learning domain. It's called federated learning to help us to utilize the data from different organizations while we can still be able to preserve the privacy of the data. Google released 2 papers in 2017 talking about some techniques about federated learning. The idea is for example, in the left-handed example, the Android phone devices, they have an agent collecting some of the user data and perform local training. And when they have a local model, they can aggregate the model and send to the cloud, a central place in the cloud to build a globally optimized model. And then this model is pushed back to the device side for better performance or better accuracy of the prediction. During this process, the user's data are encrypted and sent to the central place in the cloud. And then they can cancel out with each other when they add them together. So in this way, the privacy of the user data is protected, and still, like Google can still to build a useful model for the Android phone users. So right now, there has been quite a few years development in the academic world as well as in the industry. So right now, there's some of the use cases that are quite interesting. Here, I mean, in China, we have a few interesting use cases in the finance and other area. For example, in this case, in the central bank and the commercial bank, they are working together to find out the anti-money laundering activity in the transactions. Normally, the central bank and the commercial bank cannot share data with each other, but they can use the federated learning technology to protect the privacy of the data and still be able to build an interesting data model can be used for the machine learning algorithm to achieve some of the prediction model that can detect the anti-money laundering activity. So there are many other use cases like in social networking with the bank, using the data collectively to build interesting model for insurance company, for retailers, and so on. So if you want to do some of the to build some of the federated learning machine learning applications, we need some powerful tools. We need some powerful tools for the training. There's an open source project called FATE, a Federated AI Technology Enabler, that can help us to do so. The FATE was initiated by WeBank and the first internet bank in China. and was donated to Linux Foundation early June this year. They have been the first industry-level federated learning framework to work on the to provide an out-of-box usability for the federated learning. And our team here in China has been working with them for some of the deployment using container and cloud-native technologies, and as well as other community members are working on this in this area too. Here's basically the idea is very simple. I mean, so each of the party is the participating party. They can have their own set of fate deployment, and then they work with the exchange component together to change the data and collectively build a model. And then inside each of the party, they will have many components here, as shown here, like about 10 components here, and some of them can be scaled out or scale components. So we see that it's very complicated for them to build or run the data. So we containerize all the components hit there, and then they no longer need to compile the source code from the source code, and we can use Docker Compose to deploy the Fate platform. And then we also have the Helm chart for the Kubernetes deployment for this Fate components. And so by using this cloud-native technology, they save a lot of time from deployment of the containers. So normally they need 1 day or 2 to deploy the Fate system, but using the container technology, they only use about 1 to 2 hours. So it's a lot of saving in time. Also, we use Harbor here to manage the container image and Helm charts. So the container image can be replicated from Docker Hub in a regular way, so that when there's a new version going to the Docker Hub, they can be automatically replicated to local repository. And also by setting up a Harbor registry locally, they can have offline image and also have the Helm chart imported into the Harbor, so that they can have offline access for the deployment and also for the operation for the local clusters. So that's reduce the complexity of the operations. So this part of code is right now in a project called KubeFate, and also it's alongside with the open source project called Fate. So both of them are is open source under the namespace of Federated AI. And if you're interested, you can go take a look and see how we use Harbor there for the image management and Helm chart management. I think that's all, Stephen.
Okay, great. Thank you, Henry, for the great share. I think this is the first use case Harbor used in the machine learning or AI scenario. So, as we don't have enough time for you guys to ask a question, so if you have any question, you can post it to the WeChat channel or Slack channel about the 2.0 Harbor version, about the GitHub action, about the Harbor in Fate. So, thank you everyone for your joining. Per time limitation, we'll close this meeting today. Thank you, guys.
Thanks everyone. Bye-bye.
Bye-bye.
Thanks. Bye-bye.